Okay, here's our review. So we're going to do Chapter 6 first, and then we'll do as much as we can today. It says, find the sum of the measures of the interior angles of a polygon with 14 sides. So let me just tell you, what's the best way to do this? Let me just kind of... Tell you what, let me just copy this. And then... It says find the sum of the measures of the interior angles. I think we'll just do it like this. I'll just kind of keep going back and forth. How many 14 sides? Is that what we're doing? So I'm just going to write down 14 sides. And there's a formula that we have to know. And it's n minus 2 times 180. That's the sum of the angles, and that's what it asks for. It says the sum of the interior angles of a polygon with 14 sides. So what do? You just go 14 minus 2. The n represents how many sides you have, times 180. Alright, 14 minus 2 is 12, so whatever 12 times 180 is, let's see what that is. 12 times 180. Oops, let's try that again. 12 times 180. And that's 2160. Pretty simple. But you got to know the formula. If you don't know that, you wouldn't know how to do that problem right there. Number 2. I'm going to have to keep going up and down, but that's okay. It says the measure of an interior angle of a regular polygon is 160 degrees. It says find how many sides you have. So this time they're telling you each interior angle is 160 degrees. How many sides do you have? Let's just draw a little picture just so you can kind of visualize what's going on. So it says each interior angle is 160 degrees. Now you could do it a couple different ways. This is what I found, I think, to be the easiest as far as the arithmetic goes. What I'm going to do is this. I'm going to actually look at the exterior angle. If this is 160, what's the exterior angle going to be? It's going to be 20 degrees because that's 180. Now, if the exterior angle is 20 degrees, what do all the exterior angles add up to be? What's the sum of all the exterior angles? No, the sum of all the exterior angles, not just one, 360, right. So if I take 360 divided by what? By 20, that's going to tell me how many exterior angles I have. Well, I got the same number of sides as I have exterior angles, so if I know how many exterior angles are going to be, it's the same number of how many sides they're going to be. So I can just do this. Okay, the zeros cancel. I can do that in my head. What's that? 18. And so there you go. So it's a polygon with 18 sides. So technically we were finding out how many exterior angles we have, but it's the same number of sides. And that's how I would do that problem. Number 3. Let's jump back up here again. It says find the measure of each interior angle of a regular polygon with 16 sides. So it sounds like it's the same problem as number 1, but this one said find the sum of all the angles. That means all the angles added up. This one says find what? Each interior angle. And it's got 16 sides. There's a couple ways you could do this, but this is probably the best way. If you look at number 1, we could find the sum of all the angles, so let's do that. So it would be 16 minus 2 times 180. That's going to give me all the interior angles all together. But if there's 16 sides, how do I find each interior angle if it's a regular polygon? This gives me the sum of all the angles. How do I find just one of the angles? Divided by what? How many sides I have. That's right. Divided by how many sides, which would be 16. So you throw that in your calculator and you see what you get. Well, 16 minus 2 is 14, so it's just, oops, turn that on. So it's 14 times 180, and then take that and divide it by 16. And there you go, 157.5. It's 157.5, and that's how many degrees? That's degrees. So that's each, right? Each interior angle would be 157.5 degrees if you had a 16-sided figure. That's probably the easiest way to do it. There's other ways to do it, but that's probably the best way. If you want to find each one of them, right. Now, if I would have just gone 14 times 180, that would give you a number something like this, right? And that would tell you the sum of all the angles. So make sure that you understand what the problem says. This problem said find the sum of all the angles. This one said find each of the angles. So I have to divide it by how many sides that I had. That's why I did that. So I divided this by 16, and I didn't divide this by anything, because this tells me all the angles all together. 2160, 2,160 degrees. Okay, enough of that. Number 4. Tell you what, I'm just going to, well, we'll just look up here. Sorry, I got to keep going back and forth, but don't know a better way. Let's just look at it. So we could probably even write it up here. Let's see. All right, look at this. It says solve for x. So we'll just write it up in here. There's something that you have to realize that's true about this thing. Now this thing, look, the opposite angles are equal, aren't they? It's a four-sided figure, so it's a parallelogram. So what I have to do is I got to solve for x. Now, if I just set x equal to x, would I be able to solve for x that way? No, I wouldn't. If I just set this equal to itself, I couldn't solve for x. There's another relationship, though, with a parallelogram. It's between these two angles. What's true about these two angles? They equal 180, right. So that's what we're going to use. So 2x minus 15 plus x equals 180. All right, and then we do the math. That's 3x equals, what's that, 195? Right, because I added 15 to both sides. Divide by 3, and whatever 195 divided by 3 is, 195 divided by 3, and that's 65. Okay, so that's 65. So x is 65, and that's all they ask you to solve for. They don't ask you to find this angle or anything. They just say solve for x. That's all there is. Yep, pretty easy stuff, isn't it? Yeah, I think this is probably one of the easier chapters. I think chapter 6 is the parallelogram chapter. If you know some stuff, you got to know some stuff about the parallelograms. Though. Look at this. This is really simple. Look at these. It says find the value of each variable. So you got to find a and b right here. Well, it says for each parallelogram. So you know they're parallelograms. So what's true about the opposite sides of a parallelogram as far as the lengths are concerned? They're equal to each other, so you just set those equal to each other. So 3a minus 5 equals what? 2a. All right, subtract a 2a from both sides, I get a. Add a 5 to both sides, I get 5, and that's all there is to it. All right, just got to know some basic Algebra 1 skills. Look at this. What about these two sides right here? It's a parallelogram. They're going to be equal to each other, so we just set them equal to each other. So 2b minus 1 equals b plus 3. Subtract b from both sides. 2b minus b is b. Add a 1 to both sides. b is 4, and there you go. b is equal to 4. Simple, isn't it? Yeah. Nope, because I added a 5. I subtracted a 2a. I got a. Then I added a 5, and I add a 5 to 0. 0 would have been over here, so it's positive 5. And they don't ask you to find the lengths of the sides. They just say solve for the variable. So there you go. All right? Does that make sense? Let's do another one. What are we going to do here? Look, these two are equal to each other, but if I set them equal to each other, could I solve for either x or y? Right, so what I have to do is this. I got to look at these two things right here. And I got to say, just like we did earlier, right? We determined earlier that these two angles right here are supplementary, which means they add up to 180. So you're going to have to add them up, set them equal to 180. So I've got 3x plus x plus 8, and that equals 180 degrees. This is 4x. Subtract an 8 from both sides, and that's 172. Divide by 4. Let's see, I don't know what that is. 172 divided by 4, and that's 43. Yeah, I've never been able to. Yeah, it's 43. Okay, so x is 43. So that's what x is equal to. But we also have to find something else. What else? Got to solve for y, correct? So let's do this. Let's go. Let's figure out what this angle is right there, and this angle is going to be the same angle. Remember, they're equal to each other. So 3x. So 3 times 43. 3 times 43, and that's 129. So this angle right here is 129 degrees. Well, why do I care about that? Because this angle up here is equal to the same exact thing, isn't it? Because the opposite angles are equal to each other. So what I can do is this. I can go y plus 9 equals whatever this angle is. This angle is 129. This angle is 129. So I can just say y plus 9 is the same thing as 129 degrees. Right? Solve for y. That's simple. Subtract 9 from both sides. You can do that in your head. What is it? It's 120. So there's y. We good with that? It's pretty easy, isn't it? Let's do this. I don't have to go over that far. It was even more easy. Yep. Let's do a different color here. Let's go with this red. All right, let's look at this. This time, they're diagonals that intersect inside each other. Now, what happens on a parallelogram when the diagonals intersect like this? What's true about the two segments that they make? This segment is what? Equal to this one. And this one right here is equal to this one right here. They bisect each other, is what our formula says. So this segment and this segment are equal. So again, it's just basic arithmetic, basic algebra 1 stuff. You just set them equal to each other. So 3y minus 1 is equal to y plus 5. Subtract y from both sides, you get 2y. Add a 1 to both sides, you get 6. Divide by 2, you get 3. Simple as that. The algebra is easy, isn't it? Right? It's like pre-algebra. It's not even algebra 1 stuff. Let's solve for x. So these two are going to be equal to each other. Is that a minus 2? It is, yep. So let's try to slide this in here. So what is it? 4x minus 2 equals, I have to scooch this over. 4x minus 2 equals x plus 10. Alright, so let's just do the algebra. Do it quick. Subtract the x from both sides, I get 3x. Add a 2 to both sides, I get 12. Divide by 3, and x is 4. There you go. That's your answer for that problem right there. What are you thinking? Pretty good, huh? It says determine if this is a parallelogram or not. Right? There is a theorem. Look it up in chapter 6. There is a theorem that says if you have one pair of opposite sides that are both parallel, and they are, and equal to each other, they are. If you just have one pair that have both of those things true, yes, this thing is a parallelogram. And that's all you have to do. It just takes a couple seconds to look at it. What about this one right here? Now, I don't know anything about them being parallel or the sides being equal, but there's another thing in this chapter that says if the opposite angles are what? Are equal to each other, then it's a what? It's a parallelogram. So is this a parallelogram? Sure it is. Okay, the opposite angles are equal to each other, so yes, it is a parallelogram. That's all there is to that. That was quick as anything, wasn't it? Alright, we good? That was nice and easy. Let's tell you what, let's make this a little bit smaller so it fits in the viewing screen here. Alright, let's look at this. Here's our rectangle that we're going to use. Are you watching? Here's our rectangle, so let's put some stuff in here. UZ is this little bit right here, is x plus 21. Make this a little bit bigger. Okay, so this is x plus 21. That right there. That's supposed to be a plus. And then what else does it say? ZS is 3x minus 15. That's this bit right here. 3x minus 15. Well, that should look familiar, right? We just did one like this. Find US. Find the whole entire line segment. So what's true about these two parts right here? They got to be equal to each other. Remember, it's a rectangle, which is a parallelogram. So the diagonals bisect each other. That means that this is split in half. So this and this are equal to each other. So let's set them equal. I always like putting the bigger number, the bigger version of x on the left-hand side. So it's 3x minus 15 equals x plus 21. X plus 21. Alright? And now let's just solve for x. Subtract x from both sides, I get 2x. Add a 15 to both sides, and I get what? 36. Divide by 2, x is 18. Do I circle that? Is that my answer?
No.
Why not? What's it ask you to solve for? US. Okay, so I got to find that whole entire thing, don't I? So let's just find this little bit right here first. So this is x plus 21. So what do? I take that x and I add it to 21, and that gives me 39. So if this is 39, what's this right here?
39.
Right, so if that's 39 from here to here, this has got to be 39 as well. So what do we do to find that whole entire US? Add them up. And so what's that? I think it's 78, isn't it? Right? 9 and 9 is 18, right? So it's an 8 on the bottom, right? 1 on the top, carry the 1. 6 and 1 is 7, 78. So US would be 78. We good with that? It's not so bad, is it? Tell you what, let me get rid of some of this because I used up all my writing room. Let's get rid of that. Boom. There we go. Alright. Let's do the same. Well, I'm trying to fit it all in there. Alright, it says, if the measure of the angle, so this is an angle right here. Angle SUT. Let's find it. SUT. That's this angle right here. If that angle right there is 3x plus 6, I'll just write it right here. 3x plus 6. And then it says angle RUS. RUS, this angle right here is, this one right here, is 5x minus 4. 5x minus 4. Question says, find angle SUT. So find out what the actual measurement is, what the actual degrees is of this thing right here. Well, what's it say about this thing? It say what? It's a rectangle. So what kind of angle do we have here? It's a right angle. So what is this angle right here and this angle here? What do they do? Do they equal each other?
No.
No, we don't know they equal each other. What do?
They add up to 90.
Very good. They add up to 90 degrees. Do you see that? How do you know it's 90 degrees? Because it's a rectangle. And a rectangle means that's 90 degrees right here. So this and this add up to 90. I know it's a little sloppy, but let's... So 5x minus 4 plus 3x plus 6 equals what? 90 degrees. Everybody see that? Alright, good. Because it's a right angle. This angle and this angle form this right angle. So they add up to be a 90 degree angle. 5x plus 3x is 8x. Negative 4 plus 6 is positive 2 equals 90. Subtract a 2 from both sides. So 8x equals 88. Divide by 8, x equals 11. But they don't just say solve for x, they say what? Solve for angle SUT. SUT, this one right here. So I know what x is, now what do I got to do? I got to take x and then plug it in, right? For that x right there. So it's 3 times 11 plus 6, that's 33. You can do it in your head. 33 plus 6 is 39. So that angle right there, this angle right here, is 39 degrees. Okay? Don't just think we always just solve for x, because they don't say solve for x, do they? You had to solve for x, don't get me wrong. You still had to solve for x, but you solved it in order to find that angle right there. Alright, enough of that. This chapter seems pretty easy now, doesn't it? Let's get rid of some stuff here. Let's get rid of all of this. Alright, just give myself some room here. Alright, let's change colors now. Let's go to this orange. Alright, let's look at this. It says angle 1 is 40 degrees. So this angle right here, okay, is 40 degrees.
Angle 4 is 40.
What's that?
Angle 4.
Okay, well, let's look at it. It's a rectangle, right? So look what we have. We got parallel lines in. If it's a rectangle, those two sides right there are parallel to each other. So angle 1 and angle 4 are alternate interior angles, right? So without doing any real math at all, angle 4 is 40 degrees. Didn't have to do any arithmetic at all. We just had to recognize that they're alternate interior angles. The question right here says find angle 2. Well, that's not hard. It's basically what we just talked about over here. This is a rectangle. It's not just any old parallelogram. It's a rectangle. So that must mean that's 90 degrees. So if this is 40 degrees, how do we find angle 2? Subtract it from 90. So 90 minus 40 is 50. Right? It's an ugly 50, but that's what it is. Okay, so it's 50 degrees. Simple. These are pretty quick, aren't they? Wow, we might even finish this whole thing. I don't know. Maybe not. Let's take a look. A rhombus. What's true about a rhombus? What's true about all sides? They're all equal to each other. Okay? Let's put some numbers in. RK is 5. So that little bit right there is 5. RY, this top one right here, is 13. And then angle YRZ. YRZ. Wow. Tell you what, let's put this 5 right here. YRZ, this angle right here, Everybody see that angle? 65 degrees. 65 degrees. Sorry, it's a little small, but I think you get it. Now, this is a rhombus. Here's something that you need to know. What are we trying to find? We're trying to find KY, this one right here. All right? Everybody watching? Here's something you need to know about a rhombus. The diagonals, they do bisect each other, just like we talked about before, but specifically on a rhombus, they don't do this with just a regular rectangle or just a regular parallelogram. They only do this when all four sides are equal to each other. What do? What kind of an angle is formed here?
90.
It's a 90 degrees. Do you remember that? That's something that you may have forgotten. We haven't talked about in quite a while. But on a rhombus, the diagonals are perpendicular, which means it's a 90-degree angle. So look what I have. If I wanted to find KY, this one right here, basically I have a right triangle. Tell you what, let's... So I'm going to redraw that triangle. Just, that's terrible. I probably should have made that one a little shorter, but anyway, you get the idea. Alright, let's say that that's that triangle. Everybody see that? So what was this length right here? That was 5. What was this one up top? 13. Now, this is a point where it's really helpful, saves you quite a bit of time, to recognize one of those. That's right. If you recognize, remember 3, 4, 5. We all remember 3, 4, 5, but there was another one. 5, 12, 13. If you can remember that, that's great. If you can't remember it, then what do you have to do? No, not just Pythagorean theorem, right? Do Pythagorean theorem. But isn't it a lot better just recognizing 5, 12, 13 than having to go through the whole Pythagorean theorem? Absolutely. Okay? So that's what this is right there. That's 12. Now let's see what we're going to try to find. Tell you what, let's get rid of some of this mess since I've already dealt with it. Oh my goodness. Let's try this. There we go. Alright, YZR. Where's that? YZR. This angle right here. Now remember, this angle up here was 65 degrees, wasn't it? YRZ. That one's 65 degrees, and we're trying to find this angle right here. What do you think?
That's easy. You subtract it.
Well, what's true about the diagonals? Okay, they're perpendicular, but the opposite angles are what? Are equal to each other, and the diagonals on a rhombus, am I right on that? Yeah, diagonals on a rhombus do what to each other? They bisect each other, right? So look, if this angle is exactly the same as this angle, and if they're both being bisected, then if this is 65, guess what? That one right there is also got to be 65. All right, so that's that angle right there. That's 65 degrees. Does that make sense? Okay, good. Think we have time to finish the rest of these? No? 3 minutes?
Actually, 2 minutes.
Let's do that. Why is that line through there? I don't know why that line's through there. There we go. Got rid of that line. Alright, let's make it bigger. Okay, here we go. Alright, let's look at this. This is a trapezoid. Why did that line kind of go away? There we go. We'll put it in there. Yeah, let's do this. We should get done this section. Watch this. It's a trapezoid, and it says T and S are midpoints of the legs. So T and S are midpoints. That means this and this are equal to each other, and this one are equal to each other. Let's put some numbers in. HJ is 8, and LK down here is 14. Find TS. Well, you just have to remember there's a relationship between these. You got to know what it is to be able to do this. What do we do to these two to find TS? Do you remember? So if I wanted to find TS, does anybody remember what we do to those two numbers to get this? This is basically, TS is basically the average between these two bases right here. So if this was the average between these two bases, what do we do to find the average? Take 8 to find the average of two numbers. Come on. Add them up, right? And divide by 2. So what's that? 22 divided by 2, which is 11. So that right there would be 11, and that's your answer. All right, we'll finish that up. Well, I'll probably finish this up in fourth period tomorrow, so it'll be on YouTube if you want to find the rest of these.